Hare Krishna. So student, this is my sixth video, and today we have to study about the inverse trigonometric function, the derivative of a inverse trigonometric function. Again, it's very important. In this unit there are so many formulas, isn't it? And the problem depending upon that formulas. So you should know all the formulas. I will also going to state you all the formulas of the inverse trigonometric function. Now what do you mean by the inverse function? What do you mean by the inverse? When the inverse of a function is exist. When the function it is 1 1 and onto, when your function it is 1 1 and onto, then and only then the inverse of the function get exist. Now what do you mean by the 1 1 function? See here, suppose this is the set A and suppose this is the set B, isn't it? And suppose I have denoted the element of the set A, it is denoted by X, and the element of the set B, it is denoted by Y. Suppose this is 1 2 3 4, this is 1 4 9 and 16. When the every element of the set A has only one and only one image in the set B, that is 1-to-1 combination, that is every element of the set A has one and only one image in the set B, then that is called as a 1 1 function, isn't it? And what do you mean by the onto function? If the function is 1 1 and onto, then and only then the inverse of a function get exist, isn't it? Therefore here, when the every element of the set B has some pre-image, in the set A, then it is called as a onto function, right? जो set A और set B है, इसमें का जो every element है, whatever the elements in the set A must have one and only one image in the set B, and that is called as a 1 1 function. That is called as a 1 1 function. And when the every element of the set B has some pre-image in the set A, then that is called as a onto function. And if the function it is 1 1 and onto, then and only then the inverse is exist. Suppose I write the function like this: y is equal to f of x. Then if this function it is 1 1 and onto, then and only then the inverse exists, and that is x is equal to f inverse of y. Suppose y is equal to sin x. If this is 1 1 and onto, then x is equal to sine inverse of y, isn't it? Y is equal to cos x. Then you can write as a x is equal to cos inverse of y. Such a function it is called as a inverse function, right? This is the inverse function. This is called as a inverse trigonometric function. If your function it is 1 1 and onto, then and only then the inverse of the function get exist, right? Again, how will you find out the derivative of a inverse trigonometric function? Again, one of the theorem, and that is very important on the view of the board, isn't it? In board they ask the theorem, that is the first theorem, the first important theorem, that is the chain rule, and the second important theorem, that is the inverse function, isn't it? That is the theorem on the inverse function. See the theorem here. See the theorem: if y is equal to f of x is the function of x, which is 1 1 and onto, then x is equal to f inverse of y, and prove that dy by dx it is equal to 1 upon dx divided by dy, right? Again is the differentiable function. You have to write as a differentiable function of x, which is 1 1 and onto. Then x is equal to f inverse of y. Then we have to prove dy by dx it is equal to 1 upon dx divided by dy. Again you have to make the star here, because sometimes they ask in the board also, what is the first important theorem? That is the chain rule. What is the second important theorem? That is the theorem on the inverse trigonometric function, isn't it? Y is equal to f of x is a differentiable function of x. What is the meaning of differentiable function? Means the derivative of a y with respect to x get exist, isn't it? And since it is 1 1 and onto, the inverse function also exists, then we have to prove that dy by dx it is equal to 1 upon dx divided by dy, right? Now suppose 3 by 5, then you can write as a 1 upon 5 by 3, isn't it? But this is what your numerical number. This is the real number. But this is a derivative. dy by dx is the derivative of a y with respect to x, and this is the derivative of a x with respect to y. And the derivative, it is changes from function to function. Therefore directly you can't write like this. We have to prove this, isn't it? So dy by dx we have to prove as a 1 upon dx divided by dy, right? Again, to get this, you know the definition, limit derivative, the definition of a derivative, limit del x tends to 0, del y divided by del x, it is equal to dy by dx. Therefore, unless and until you take the change in the given function, you can't get a dy by dx, also you can't get dx divided by dy, isn't it? Therefore, you have to start with a changes. Let del x be the small change in x corresponding a small change del y in y, right? Therefore we can write del y divided by del x, it is equal to 1 upon del x divided by del y, because the every numerical number, real number, that is suppose 4 by 3, this you can write as a 1 upon 3 by 4. These are the changes. This is a real number, this is the any numerical number, this is not the derivative. Therefore this identity you can write in this way, because del y del x, this is nothing but the changes and this is the real number. Now you have to take the limit as usual. Limit del x tends to 0, del y divided by del x, and here also you have to take the limit del x tends to 0, del x divided by del y, right? Now by the definition of a derivative, here you can write directly dy by dx, but to apply the definition of the derivative, here we want in place of del x, we want what here del y. Again, in place of del x, how will you write del y, isn't it? Now again, you know, this is first here, again no, since y is the function of x, and as del x tends to 0, now obviously del y also tends to 0, because y is the function of x, y it is depend upon x. Whenever the change in the value of a x, it is approaches towards 0, therefore the corresponding change in the value of a y, it is also approaches towards 0. Got it? Because the change in the value of a x, isn't it? देखो इसमें का अगर चेंज 0 का अप्रोच हो रहा है तो y का इसमें जो y में जो चेंज है दैट इज आल्सो अप्रोचेस टुवर्ड्स 0, बिकॉज y is the function of x, y it is depend upon x, therefore as del x tends to 0, the del y also tends to 0, right? When the change in the value of x, it is approaches towards 0, therefore the corresponding change in the value of a y also approaches towards 0. Therefore in place of del x, you can write what here del y. Therefore here see, limit del x tends to 0, del y divided by del x, it is equal to 1 upon limit del y tends to 0, del x divided by del y, right? Therefore directly here you can write dy by dx, it is equal to 1 upon dx divided by dy, and this is by the definition of derivative, isn't it? Derivative. So this is about dy by dx, it is nothing but 1 upon dx by dy. This is the very important theorem, right? On the view of a board, isn't it? The board में ये यानी पूछ सकते हैं. So this is very important. So you have to remember this and you have to make the star mark, isn't it? Star mark. The first is the chain rule and this is second is the inverse function. Now there are the proposition. Again here we have to find out the ddx of, that is the derivative of a sine inverse x. There are the 6th inverse trigonometric function. Which are they here? That is say sine inverse x, cos inverse x, tan inverse x, cot inverse x, cosec inverse x and sec inverse x. isn't it? जैसे साइन कॉस टैन सेक कोसेक कॉट, these are the trigonometric function, but sin inverse x, cos inverse x, tan inverse x, cos inverse x, cot inverse x, cosec inverse x, sec inverse x, these are also the inverse trigonometric function. And here again, how will you find out the derivative of a inverse trigonometric function? Again, there is a one proposition. See here, the proposition 1. Proposition 1. First proposition, if y is equal to sine inverse of x, then prove that dy by dx it is equal to 1 upon root of 1 minus x square, isn't it? Now see here, proof of this theorem, proof of this proposition. Now let y is equal to sine inverse x, right? This is 1. Therefore, x is equal to sine y, right? Now you know the range of a sine function. The sine function always takes the value 1, minus 1, and in between 1 and minus 1, isn't it? Therefore here the x belongs to, see here, the x belongs to the closed interval minus 1 to 1, and since x belongs to 1, therefore that is the y belongs to, that is minus pi by 2 to pi by 2, because the sine pi by 2 it is always equal to 1, and sine of minus pi by 2, sine of minus theta minus sine theta, right? Therefore this is minus 1. As x belongs to minus 1 to 1, therefore y belongs to minus pi by 2 to pi by 2, right? Now see what you have to do. This is second. Again, since x is the function of a y, you have to differentiate with respect to y. See, you have to differentiate with respect to y. Now here dx divided by dy, that is dy of sin y. जैसे sin x की डेरिवेटिव क्या आती है cos x, वैसे sin y डेरिवेटिव, because this is dy of sin y, the derivative with respect to y, and your function it is also in the form of a y. Therefore you can find out directly the derivative dx divided by dy, it is equal to cos y, right? But you know, see here, dy divided by dx, it is nothing but what here, 1 upon dx divided by dy, right? Therefore dy divided by dx, it is nothing but 1 upon, that is equal to cos y, right? Here you have got the derivative, but we want dy by dx, it is nothing but what here, 1 upon root of 1 minus x square. This cos y you have to find out in the form of a what here, x. Therefore see what you have to do. You know the identity, that is sin square y plus cos square y, it is equal to 1. This is the identity. Now what is the value of a sin y? That is equal to x. Therefore here you can write x square cos square y, it is equal to 1. Therefore cos square y, it is equal to 1 minus x square, and here again cos y, it is equal to plus minus root of 1 minus x square. Now the question is whether you have to take positive or whether you have to take negative, because here you have to substitute the value of a cos y. But there are the two values of a cos y, that is plus and minus. Which value you have to choose, that is depend upon in which quadrant this angle lies. If you observe this, y lies in a closed interval minus pi by 2 to pi by 2. Now you know, see here, if you observe this, the directed angle, this is 0. From up to this is pi by 2, this is pi, this is 3 pi by 2, and this is what here, 2 pi. Isn't it? 0 to pi by 2 lies in the first quadrant, and 0 to minus pi by 2, this is also, when we consider the angle in a clockwise direction, you have to take the negative, and in anti-clockwise direction, the sign of the angle, it is regarded as a positive, right? This is anti-clockwise, therefore the angles are positive, and this is clockwise, therefore the angles are negative, isn't it? Therefore this is 0 to minus pi by 2, this is lies in what here, fourth quadrant, and 0 to pi by 2, it is lies in what here, first quadrant. When y lies in the minus pi by 2 to pi by 2, means this y lies in which quadrant here? That is the first and the fourth quadrant. And in the first and fourth quadrant, the cos is always positive. In the first quadrant, all the ratios are positive. And in the fourth quadrant, the cos and sec ratio, that is the cos x and sec x, it is positive, isn't it? Therefore, since y lies in first and fourth quadrant, therefore cos y is positive in first and the fourth quadrant. Therefore, you have to choose the positive value of a cos y, that is 1 minus x square, right? Suppose this is third, then you have to put this value, put cos y, it is equal to root of 1 minus x square in third. Here you have got dy by dx, it is nothing but 1 upon root of 1 minus x square. Again d dx of, what is your y? Y, it is nothing but sine inverse x. Therefore, the d dx of sine inverse x you have got as a 1 upon root of 1 minus x square. This is the again important proposition, that is, the if y is equal to sine inverse x, if your function it is in the inverse form, that is the inverse trigonometric function, then the derivative of a sine inverse x, it is equal to 1 upon root of 1 minus x square. And how will you prove this? In this way we can prove this, right? Similarly, I will take the another proposition, that is here cos inverse x. See, cos inverse x, and here the derivative of a cos inverse x, that is minus 1 upon root of 1 minus x square, right? Again see the proof here. Let the function it is given as a cos inverse of x, this is first, right? Therefore we know x is equal to what here? Cos y. This is second. Again the cos function always takes the value 1, minus 1, and in between 1 and minus 1. Therefore, the x belongs to the closed interval minus 1 and 1. On that ground, the y belongs to, that is 0 to pi, because the value of a cos 0, that is always equal to 1, and the value of a cos pi, it is equal to minus 1. Therefore, this y, it is ranging from 0 to pi, isn't it? Therefore, here x belongs to minus 1 to 1, and the y belongs to 0 to pi, right? Again, x is the function of a y, you have to differentiate with respect to y. Therefore, dx divided by dy, it is equal to cos y, the derivative of a cos y, that is equal to minus sin y, right? But we know dy divided by dx, it is nothing but 1 upon dx by dy. In the first theorem we have proved. Therefore, dy by dx, it is equal to, that is dx divided by dy, that is equal to minus sin y. You can write minus 1 upon sin y, isn't it? Now this is what here third. Again, we have found it the dy by dx, but here we want to find out dy by dx, it is nothing but what here? Minus 1 upon root of 1 minus x square. Again we want sin y, it is in the form of x, right? Therefore, again we have to use the identity, that is sin square y plus cos square y, it is equal to 1, right? Now what is the value of a cos y? That is equal to x. You can substitute here cos y, that is x means x square, sin square y plus x square, it is equal to 1. Therefore, sin square y, it is equal to 1 minus x square, and sin y, it is equal to plus minus root of 1 minus x square. Again the question is whether you have to take positive value or whether you have to take negative, isn't it? That is depend upon again the y, in which quadrant this y lies, right? See again, if you observe this is 0 to pi by 2 and this is pi by 2 to pi, right? Therefore, 0 to pi by 2 means y lies in the first and what here? Second quadrant, right? So, since y belongs to the first and the second quadrant, and sin y, it is positive in the first and the second quadrant. In the second quadrant, in the first quadrant, all the ratios are positive, isn't it? No doubt here. In the first quadrant, all the ratios are positive, but in the second quadrant, the sine and the cosec function are positive. And here, this y lies in what here? First and second quadrant, isn't it? And sin y, is positive in first and second quadrant. Second quadrant. Therefore, which value of a sin y you have to consider? Sin y is equal to root of 1 minus x square. You have to consider only the positive value. Now here you can substitute, put in third. You will get dy by dx. It is equal to, this minus sign remain as it is, minus 1. And here, what is sin y? Root of 1 minus x square. And ddx of, what is the value of a y? Y, it is nothing but the cos inverse of x. Therefore, the another formula you have got, that is the derivative of a cos inverse x, it is equal to minus 1 upon root of 1 minus x square. Right? Now, the third one, third propositions here, that is tan inverse x. The third proposition, that is y is equal to tan inverse x. Right? And we have to prove dy by dx, it is equal to 1 upon 1 plus x square. Right? Again, see the proof. Let y is equal to tan inverse x. Right? Therefore, x is equal to what here? Tan y. This is first, this is second. Again, x is the function of a y. You have to differentiate with respect to y. Isn't it? Therefore, dx divided by dy, that is ddy of tan y. And what is the derivative of a tan y? That is equal to sec square y. What is the ddx of a tan x? Sec square x. In the similar way, the ddy of a tan y, that is nothing but what here? Sec square y. Right? Therefore, this is sec square y. Again, we know dy divided by dx, it is equal to 1 upon dx divided by dy. Right? Therefore, here you can write dy divided by dx, it is equal to 1 upon dx divided by dy, it is nothing but sec square y. Right? Now here, see, dy by dx, you know the identity. Again, 1 plus tan square x, it is equal to sec square x. Therefore, 1 plus tan square y, it is equal to sec square y. Therefore, in place of sec square y, you can substitute tan square y. Right? And see here, that is, what is the value of a tan y? From second, here x. Therefore, here you can substitute x. Therefore, dy divided by dx, it is equal to 1 upon 1 plus x square. And ddx of, what is y? Y, it is nothing but tan inverse of x. Therefore, the derivative of a tan inverse x, you have got as a 1 upon 1 plus x square. Right? That is the third proposition. Right? That is the third formula of the derivative of the inverse function, and that inverse function, it is tan inverse x, isn't it? Now, let us take the fourth proposition, cot inverse x. See cot inverse x, and only there is a change, minus. Right? So, dy by dx, it is equal to minus 1 upon 1 plus x square. See, very simple. Again, proof. Y is equal to cot inverse x. This is first. Therefore, here you can write x is equal to cot y. This is second. Again, x is the function of a y. You can differentiate with respect to y, dx divided by dy. What is the derivative of a cot x? That is equal to minus cosec square x. In the same way, what is the derivative of a cot y? That is equal to minus cosec square y. Isn't it? Now you know dy by dx, it is equal to 1 upon dx divided by dy. Right? That is 1 upon, this minus sign you can give in the numerator, also in the denominator, or in the middle, isn't it? Therefore, I write in the numerator, and here I write, that is the cosec square y. Because dx divided by dy, it is nothing but what here? Minus cosec square y. Therefore, this sign you can give here also, or in the middle also. Therefore, here dy by dx, it is equal to minus 1 upon cosec square y. Again, we know the identity, that is 1 plus cot square y, it is equal to cosec square y. See here, dy by dx, it is equal to minus 1. And here, cosec square y, it is nothing but what here? 1 plus cot square y. Right? Dy by dx, it is equal to minus 1 upon, what is cot y? the value of a cot y, that is equal to x. Therefore, from second, you can substitute the value of a cot y, that is equal to x, 1 plus x square. Right? Therefore, here you have got d dx of, that is y, cot inverse of x, it is nothing but minus 1 upon 1 plus x square. Right? So, the derivative of a cot inverse x, it is equal to minus 1 upon 1 plus x square. This is the fourth proposition. Now the fifth one, that is say, if y is equal to sec inverse x, y is equal to sec inverse x, sec inverse x, then we have to prove dy by dx, it is equal to 1 upon x root of x square minus 1. Right? Again see the proof here. See, let y is equal to sec inverse x, this is first. Therefore, x is equal to sec y. This is second. Again, x is the function of a y. You have to differentiate with respect to y. Therefore, dx divided by dy, it is equal to d dy of sec y. जैसे sec x की डेरिवेटिव sec x tan x, वैसे what is the derivative of a sec y? Sec y into tan y. Therefore, here you have got dx divided by dy, it is equal to sec y into tan y. Again we know that is dy by dx, it is equal to 1 upon dx divided by dy. Right? Therefore, dy by dx, it is equal to again 1 upon sec y into tan y. Now here again, the sec function always takes the value 1 and greater than 1. Minus 1 and less than minus 1. If you see the number line, this is 0, this is 1 and this is minus 1. So the sec function always takes the value 1 and greater than 1. Minus 1 and less than minus 1. 1 greater than 1, these are all the real number. Minus 1 and less than minus 1, these are also the real number. Therefore, sec function always takes the real number, but it does not takes the real number in between 1 and minus 1. Isn't it? In between 1 and minus 1, how will you write this? Suppose I write 3, 4. What is in between 3? Suppose I write 3, 4, 3, 5. What is in between here? In between, you can give in this bracket, right? Round bracket, a comma b. This is called as an open interval, isn't it? And this is, suppose the x belongs to a comma b, then x takes the value in between a and b. Suppose x belongs to 3, 5, then x takes the value, that is the decimal point. You can take the fractional values also, that is infinite number of a values. But if you consider the integer here, then what is the value of a x here? That is equal to 4. So this is the open interval, and open interval, it is useful for in between, isn't it? So the sec function always takes the value 1 and greater than 1. Minus 1 and less than minus 1 mean sec function always takes all the real values. These are also the real values, but it does not takes the real value in between 1 and minus 1. Therefore, here the x belongs to, see, the x belongs to, that is the r. X takes means sec function takes the value all the real number, but it does not takes the real number in between minus 1 and 1, isn't it? Therefore, x belongs to r minus the open interval minus 1 to 1, isn't it? Therefore, here y also belongs to, that is 0, pi, isn't it? 0, pi. But in the 0, pi, there is a one value, that is pi by 2. You know the sec y, it is nothing but what here, 1 upon cos y. And if you consider the value of a y, that is pi by 2, the cos pi by 2, it is always equal to 0, and 1 by 0, that is undefined, that is the infinity. Therefore, when you consider, when the y, it is ranging from 0 to pi, but in between 0 to pi there is a one value, that is pi by 2, and on pi by 2 the sec function, it is not defined. Therefore, you have to delete, you have to eliminate this value from this interval. Therefore, y belongs to, that is 0 to pi, but here you have to write that is y should not be equal to pi by 2. Therefore, you have to subtract this, right? Therefore, here y belongs to 0 to pi, but y does not takes the value, that is what here, pi by 2, isn't it? Now here again, the dy by dx, it is in the form of a x, right? Now you know sec y, it is equal to x, isn't it? What is the value of a sec y? That is equal to x. Now we want to find out the value of a tan y, isn't it? Therefore, you know again the identity, this is third, 1 plus tan square y, it is equal to sec square y, right? Now 1 plus tan square y, it is equal to, what is the value of a sec x here? X, here x, again this you have to write as a tan square y, it is equal to x square minus 1, and tan y, it is equal to plus minus root of x square minus 1, right? Therefore, sec y into tan y, it is nothing but, sec y means x, and this is plus minus root of x square minus 1. Therefore, here the sec y into tan y you have got as a x into root of x square minus 1, plus minus. Again the problem is whether you have to take positive or whether you have to take negative. That is depend upon again this y it is belongs to. The generally y belongs to what here? That is 0, this is pi by 2, this is pi, this is 3 pi by 2, and this is 2 pi. Isn't it? Therefore, 0 to pi by pi means it is lies in what here? First and the second quadrant. Now, if you observe this, the sec y and tan y both positive in the first quadrant. Therefore, their multiplication it is also positive. Isn't it? This is positive, this is positive. Positive, positive, positive. And in the second quadrant, the sec y and tan y both negative. This is negative, this is negative. Again, negative, negative, that is positive. Right? Therefore, you have to take the positive value of a y, since y lies in first and second quadrant. Second quadrant. In first quadrant, see here, in the first quadrant, both sec y, tan y are positive. Therefore, sec y into tan y is positive, and in second quadrant both sec y, tan y are negative. Therefore, their multiplication sec y into tan y is positive. Therefore, which value you have to choose? Therefore, sec y into tan y you have to consider as a x root of x square minus 1. Now, this value you have to put in third. Therefore, here you have got, that is, say, dy by dx. It is nothing but what here? 1 upon sec y tan y, it is equal to x root of x square minus 1. Isn't it? Therefore, this sec y tan y, it is equal to x into root of x square minus 1. Put this value here. Therefore, here d dx of, again y, see here, the d dx of y means what? That is nothing but sec inverse. So, the derivative of a sec inverse x, it is nothing but 1 upon x root of x square minus 1. This is again the fifth proposition, right? Now again, I am going to tell you the sixth one, that is y is equal to cosec inverse x. Then, what is the derivative? Only the minus sign. All C, that is the cot inverse x, cos inverse x, and cosec inverse x. The derivative of this function, whatever the C, it is started with C, all the derivatives of such a function, it is negative, right? Tan, sine, and sec, that is positive. But cot, cos, and cosec, these are negative, always negative. See here. Again the simple one. Here again the sixth proposition. Y is equal to cosec inverse x. This is first. Therefore, x is equal to cosec y. Right? Again, the cosec function also takes the value 1 greater than 1. -1 less than -1. right? Therefore cosec also take all the real number, but it does not takes the real number in between 1 and minus 1. Therefore here the x, it is belongs to what here, r minus open interval minus 1 to 1, right? In the same way the y belongs to what here, that is the minus pi by 2 to pi by 2. But if you observe this, in between this there is a one value 0, and you know the cosec y, see cosec y, it is equal to what here, 1 upon sine y. And if you consider y is equal to 0, then this is sine 0. And what is the value of a sine 0? 0. And this is what here, infinity, not defined. Therefore one such a value, it is in between minus pi by 2 to pi by 2, that is 0. But for this 0, if y is equal to 0, this function it is not defined. Therefore you have to delete this value, you have to eliminate this, that is what here, 0, isn't it? Therefore y belongs to minus pi by 2 to pi by 2, right? So again this is second. Again differentiate with respect to y, because x is the function of a y. What is the derivative of a cosec y? That is minus cosec y into cot y, right? Again you know dy by dx, it is equal to 1 upon dx divided by dy, right? That is minus 1 upon cosec y into cot y, right? Therefore here you have got dy by dx, it is equal to minus 1 upon cosec y into cot y. But this cosec y and cot y we want in the form of x, because your derivative it is minus 1 upon x root of x square minus 1. In place of cosec y you can put x, no doubt, right? In place of cosec y we can substitute x, but the question is of a cot y. Again you have to use the identity, that is the third here, 1 plus cot square y, it is equal to cosec square y, right? Therefore 1 plus cot square y, it is equal to cosec y, it is nothing but x square. Therefore cot square y, it is equal to x square minus 1. Therefore see here, the cot y, it is plus minus root of x square minus 1. Therefore the value, that is cosec y into cot y, it is equal to, that is cosec y, it is x. Therefore here you have got plus minus x root of x square minus 1. Again the question is whether you have to take positive or whether you have to take negative. Again you know y, it is belongs to what here, minus pi by 2 to pi by 2, means this is 0, this is pi by 2 and this is minus pi by 2. So the y belongs to the first and what here, fourth quadrant. In the first quadrant both the ratios are positive, that is cosec and cot y, both are positive. Therefore their multiplication it is positive. And in the fourth quadrant both, that is the cosec and cot y, both are negative. Therefore their multiplication it is also positive, isn't it? Minus minus plus, right? Therefore y lies in what here, y lies in the first and the fourth quadrant. In first quadrant cosec y, cot y, both positive. Therefore cosec y into cot y is positive, right? And in fourth quadrant cosec y, cot y, both negative. Therefore their multiplication, that is the cosec y into cot y, is positive, right? Therefore which value you have to choose? That is the cosec y into cot y, you have to choose as a positive value, that is x root of x square minus 1, right? Now put in third मध्ये ठेवा ही. Therefore here you have got again dy by dx, it is equal to minus 1, remain as it is, and here you have got x root of x square minus 1. Therefore here again see ddx of what is y, what is the value of y here? That is cosec inverse x. Therefore the cosec inverse x you have got as a minus 1 upon x root of x square minus 1, right? Here there are the sixth proposition and we have proved it, isn't it? In books or in any classes they have given already the formulas, but I have given the detail for you, isn't it? Because the detail study, that is the subject knowledge, it's very, very important in all angle, in any angle. अगर आप deep study करते हैं तो anywhere you can use this, isn't it? So the subject knowledge, that is the subject deep knowledge, it's very, very important, right? So that I have given this sixth proposition, isn't it? Sin inverse x, cos inverse x, tan inverse x, sec inverse x, cosec inverse x and cot inverse x. Therefore, see, I will give the list here, that is the formulas of the inverse trigonometric function. Formulas of inverse trigonometric function, ITF, inverse trigonometric function, that is ddx of first sin inverse x is equal to 1 upon root of 1 minus x square. Again, if you observe this, ddx of cos inverse x, it is nothing but minus 1 c, whenever there is a c, minus root of 1 minus x square. Again, ddx of tan inverse x, 1 upon 1 plus x square. Fourth, ddx of cot inverse x, again negative, minus 1 upon 1 plus x square. Again, fifth, ddx of sec inverse x, 1 upon x, root of x square minus 1. And again, cosec inverse x, ddx of cosec inverse x, that is minus 1 upon x root of x square minus 1. Means from this 6 formulae, only you have to remember this sin inverse, then comes tan inverse, and then come sec inverse. Cos inverse, cot inverse, cosec inverse, only minus. When sin inverse x, it is 1 upon root of 1 minus x square. Cos inverse x, it is minus 1 upon root of 1 minus x square. Tan inverse x, the derivative of a tan inverse x, 1 upon 1 plus x square. Automatically here, the derivative of a cot inverse x, that is minus 1 upon 1 plus x square. The derivative of a sec inverse x, that is 1 upon x root of x square minus 1. Automatically here, the derivative of a cosec inverse x, that is minus 1 upon x root of x square minus 1. Therefore, remember only these 3, and all this c, these are the minus. You have to remember this pair, sin inverse, cos inverse. This pair, tan inverse, cot inverse. This pair, sec inverse, cosec inverse. Isn't it? So, you have to use some technique. By remembering all the formulas, you have to use some technique, right? And your way you can arrange that, isn't it? So, I have given this pair, and this pair. When sin inverse x is equal to 1 upon root of 1 minus x square, cos inverse x is minus 1 upon root of 1 minus x square. Tan inverse x is 1 upon 1 plus x square. Cot inverse x is minus 1 upon 1 plus x square. Sec inverse x is 1 upon x root of x square minus 1. Obviously, the cosec inverse x is minus 1 upon x root of x square minus 1. So, these are the very, very important formulas you have to remember. Now, for the problem, again, we required so many formulas here. I will not given its range, domain and all this. Only I will give you the formulas. See. Now, see, the first one, sin inverse and sin x. It is not say always equal to x, because this angle should be within the domain of this function, isn't it? Sin inverse, whatever the domain of inverse function, that angle should be within the domain. Then and only then sin inverse and sin get cancelled, you will get x. But in general practice, sin inverse, sin get cancelled, because whenever you don't know the x, you can write sin inverse, sin get cancelled, you can write x, because you don't know the x, isn't it? Similarly, you can write cos inverse, cos x, it is equal to x. Tan inverse, tan x, you can write as a x. Sec inverse, sec you can write as a sec x, you can write as x. Again, cot inverse, cot x, you can write as a x. And cosec inverse, cosec x, you can write as a x, right? Similarly, in second span here, sin inverse x, also you can write as a x. Cos of Cos inverse x also you can write as a x. Tan inverse, tan of. Tan inverse x also you can write as a x. Cot of. Cot inverse x also you can write as a x. Sec of. Sec inverse x also you can write as a x. And cosec of. Cosec inverse x also you can write as a x. This is the second bunch. Again third one. Again very important. Now you should know sin inverse x plus cos inverse x, it is always equal to pi by 2. Right? Now this angle you can replace with any one, isn't it? Here you can write root x, but both the angles should be same. Right? This x, whenever there is x, here also x. If root x, root x. If x square plus 1, x square plus 1. If root of x square minus 1, root of x square minus 1. Right? The angle of this sin inverse and cos inverse must be same. Then and only then the value of this, it is equal to pi by 2. Very important formula. Similarly, tan inverse x plus cot inverse x, it is also equal to pi by 2. Right? Sec inverse x plus cosec inverse x also equal to pi by 2. Isn't it? Suppose I write sin inverse root of 1 minus x square, cos inverse root of 1 minus x square, it is always equal to pi by 2. Right? Instead of x, there should be the any angle. Any angle you can write here. Suppose tan inverse x square plus 1, cot inverse x square plus 1, this is also equal to pi by 2. Right? Don't stick up to this x. Right? Angle should be same. This angle, whatever you take, the inverse ratio of whatever that angle, that should be same. Right? That is the third very important one. Again the fourth, see here. The sin inverse x, you can write as a cosec inverse. The sin inverse converted into cosec inverse by taking the reciprocal of this angle, that is 1 by x. Therefore, remember, this is also very important. Whenever you have to make the sin inverse in the form of a cosec inverse, you have to take the reciprocal of this angle, isn't it? Similarly, tan inverse x you can write as a cot inverse 1 by x, and similarly the sec inverse x you can write as a cos inverse 1 by x. Right? In the similar manner also, sin inverse, tan inverse, sec inverse, you can write cos inverse x also in the form of a sec inverse 1 by x. Cot inverse x you can write as a tan inverse 1 by x, and the sec inverse you can write as a cos inverse you can write in the form of a sec inverse, cot inverse, and cosec inverse x you can write as a sin inverse 1 by x. Right? This is this three, it's very important. The sin inverse, it is converted into cosec inverse by taking the reciprocal of angle. Tan inverse, it is converted into cot inverse by taking the reciprocal of angle. Sec inverse, it is converted into cos inverse by taking the reciprocal of angle. Isn't it? And whenever you consider the pi by 2, sin it is converted into cos. Cos it is converted into sin. See here, sin x converted into cos. Tan x it is converted into cot. Sec x it is converted into cosec. Sin cos, cos sin. Tan cot, cot tan. Sec cosec, cosec sec. Taking the help of a pi by 2. You always write sin of pi by 2 minus x. It is always equal to cos x. Cos of pi by 2 minus x. It is always equal to sin x. Tan of pi by 2 minus x, it is always equal to cot x. Cot of pi by 2 minus x, it is always equal to tan x. Sec of pi by 2 minus x, it is always equal to cosec x. And cosec of pi by 2 minus x, it is always equal to sec x. Right? Therefore, whenever there is a pi by 2, 3 pi by 2, 5 pi by 2, 7 pi by 2, right? The sin it is converted into cos, cos it is converted into sin. Tan, cot, cot, tan, sec, cosec, and cosec, sec. But if you change like 5 by 2, 7 pi by 2, the sign of that result gets changed, isn't it? Only there is a difference of a sign. But whenever you use only pi by 2, the sin it is converted into cos, cos it is converted into sin, tan it is converted into cot, cot it is converted into tan, sec it is converted into cosec, cosec it is converted into sec. But Sine inverse, it is converted into cosec inverse by taking the reciprocal of this angle. Tan inverse converted into cot inverse by taking the reciprocal of angle, and sec inverse, it is converted into cos inverse by taking the reciprocal of angle. Therefore, this is very, very important. This is also important, third bunch and the fourth bunch. It is very, very important. Now see the fifth one here. Fifth bunch. See. These are the very, very important formulas. See the fifth bunch here, that is sine inverse of minus theta. You can write as a minus sine inverse of theta, right? Tan inverse of minus theta. You can write as a minus tan inverse of theta. And the cosec inverse of minus theta, you can write as a minus cosec inverse of theta. Right? In these three cases, sine inverse, tan inverse and cosec inverse, the minus sign get out of this function, isn't it? Sine inverse of minus theta, minus sine inverse of theta. Tan inverse of minus theta, minus tan inverse of theta. And cosec inverse of minus theta, minus cosec inverse of theta. And the sixth here, when you consider cos inverse of minus theta, here, that is the pi minus cos inverse of theta. This is again very, very important. See, cot inverse of minus theta, that is equal to pi minus cot inverse of theta, right? And sec inverse of minus theta, you can write as a pi minus sec inverse of theta, right? See again, this the fifth and sixth, very, very important, very, very important. Sine inverse of minus theta, minus sine inverse of theta, means sine inverse, tan inverse, cosec inverse. Minus sign take out of this function. And when cos, cot, sec, cos inverse of minus theta, cot inverse of minus theta, sec inverse of minus theta, you can write as a pi minus cos inverse of theta. Here pi minus cot inverse of theta, and sec inverse of minus theta, pi minus sec inverse of theta, isn't it? And the seventh bunch again, it's very, very important. Tan inverse of x plus tan inverse of y, it is equal to tan inverse of the formula, very, very important formula, that is x plus y divided by 1 minus xy. Again, I am not going to write the range and domain of this function where x lies and y lies. You get confused yourself. Therefore, I will give only the formula. Tan inverse x plus tan inverse y. It is nothing but tan inverse x plus y divided by 1 minus xy. And tan inverse x minus tan inverse of y, you can write as a tan inverse of x minus y divided by 1 plus xy. Isn't it? Now, this is again very, very important. This is very, very important. And the eighth one, it is not so important, but remember this, that is 2 tan inverse of x. We can write as a, the three formulas, sine inverse of 2x divided by 1 plus x square. We can prove also this, that is cos inverse 1 minus x square divided by 1 plus x square. And here the tan inverse 2x divided by 1 minus x square. This is the eighth bunch, isn't it? So this is not very important, but whenever you do the problem of the inverse derivative of inverse trigonometric function, this is very important. Whatever where I make the star mark, that all the formulas are very, very important, right? You have to by heart it, and whenever you ask, anytime, anywhere, you should know this formula, right? Once you know the formulas, then you will get the concept automatically, and you can do the problem very easily. But it should, these formulas you should know, and for by hearting this problem you have to make the more and more practice of the problem, right? जितना ज़्यादा problem करोगे, जितना ज़्यादा practice करोगे, उतने formulas याद रखेंगे, right? वो sample problem that you studied in JEE classes, that is not work for you. That is not work for the any exam, right? More and more you practice the problem, you will remember the formulas and your concept get very clear. So it is very important to know all the formulas, right? Now I will take the problem here. See the simple one. That is, suppose again here we have to use the chain rule. Again The chain rule, it is useful for the composite function. And what do you mean by the composite function? That is the combination of a two or more than two function. It is said to be as a composite function. And the chain rule, that is very, very important for this function also. Again, the first formula, that is ddx of sine inverse x is equal to 1 upon root of 1 minus x square. Right? Suppose I take the problem ddx of sine inverse of 4x. Second one, ddx of sine inverse of log x. ddx of sine inverse of e raised to x. ddx of sine inverse of cos of 4x square plus 3x plus 2. And suppose I take ddx of sine inverse of 1 by x square, right? And suppose I take here ddx of sine of cosec inverse of 1 upon log of log x. See, how will you do this? Very simple. Again you have to apply the chain rule. Now see, I will take the first one, ddx of sine inverse of 4x. Again, what you have to do? Again you have to consider this 4x as a u, because you know the derivative of a sine inverse x. What is the derivative of a sine inverse x? 1 upon root of 1 minus x square. What is the derivative of a sine inverse u? 1 upon root of 1 minus u square. But what is u? 4x. Therefore, here you have to write 1 upon root of 1 minus u square. U means what here? 4x whole square. Again, ddx of first you have to substitute u and find out the derivative. Then you have to find out the derivative of a u, whatever you put, isn't it? So, what is the derivative of a 4x? That is equal to 4. 4 divided by root of 1 minus 16x square. Got it? Here you have to substitute u. The derivative of a sine inverse u, that is 1 upon root of 1 minus u square, means what here? 4x whole square. And ddx of 4x. What is the derivative of 4x? That is equal to 4. 4 divided by root of 1 minus 16x square. Right? This is the solution of a first one. See the second one. Second one. ddx of sine inverse of log x. Right? Now again, you have to consider this is u. Right? So, the ddx of sine inverse, this you have to consider as a u. The derivative of a sine inverse u, that is again 1 upon root of 1 minus u square. What is u? Log x. Log x whole square. And again ddx of log x. So, 1 upon root of 1 minus log x whole square. And the derivative of a log x, that is 1 by x. This is the solution of a second one, isn't it? Now here, the third one. See, third, ddx of sine inverse e raised to x. Right? Here again, this is u. What is the derivative of a sine inverse u? 1 upon root of 1 minus u square. U square means what here? E raised to x whole square. And ddx of e raised to x. So what is the derivative of a e raised to x? That is e raised to x divided by 1 minus here to x. Isn't it? Now, the fourth one. See. There is a sine inverse ddx of sine inverse cos of 4x square plus 3x plus 2. Right? Now see here, be careful. If you substitute u, then what is sine inverse u? 1 upon root of 1 minus u square. Means u, what is u? Cos 4x square plus 3x plus 2. That is too lengthy. इसका अगर स्क्वायर बनाएंगे तो that is very big. That is very lengthy. So, we know the trick that cos you can convert it in the form of a sine by taking the help of a pi by 2. because I have already told you the sin it is converted into cos and cos it is converted into sin by taking the help of a pi by 2. Tan it is converted into cot and cot it is converted into tan by taking the help of a pi by 2. Sec it is converted into cosec and cosec it is converted into sec again by taking the help of a pi by 2. Right? Therefore, this cos you can convert in the form of a sin. See here, very simple. Sin inverse. This you can write as a sine of pi by 2 minus theta means this theta, that is 4x square plus 3x plus 2. Right? Now again in general practice, sin inverse sin get cancelled and what is remain here, that is d dx of pi by 2 minus 4x square minus 3x minus 2. Right? Now it is very simple to find out the derivative. The derivative of a pi by 2, that is constant, and what is the derivative of a constant? That is 0. What is the derivative of a minus 4x square? That is minus 8x. And what is the derivative of a minus 3x? That is equal to minus 3. So it's very simple, isn't it? Therefore means don't take any tension about such a big problem is there, because there are the tricks, right? So cos you can convert in the form of a sin by taking the help of a pi by 2. Such a problem you have to remember, isn't it? Again next one, that is fifth one. See, d dx of sin inverse 1 upon x square. Right? Again you know, suppose you try to find out, that is suppose you substitute u, then 1 upon root of 1 minus u square means 1 upon x square whole square, and d dx of 1 upon x square. That is little bit complicated, isn't it? But if you convert sin inverse, you can convert the sin inverse into cosec inverse and cosec inverse into sin inverse by taking the reciprocal of an angle. Cos inverse converted into sec inverse by taking the reciprocal of an angle. Tan inverse converted into cot inverse again by taking the reciprocal of an angle. Therefore here you can write, that is sin inverse converted into cosec inverse by taking the reciprocal, that is 1 upon x square you can write as x square, and it is quite easy. What is the derivative of a cosec inverse x? 1 up minus 1 upon x root of x square minus 1. Isn't it? Therefore, what is the derivative of a cosec inverse? This you have to consider it as a u. Minus 1 divided by u. U means x square. Root of u square. U square means x to the power 4 minus 1. And d dx of x square. Right? Therefore, here, what is the d dx of x square? That is equal to 2x. Therefore, here you have got minus 2x divided by x square root of x to the power 4 minus 1. Again one x get cancelled. You have got minus 2 divided by x root of x to the power 4 minus 1. Such a tricks you have to remember. It's again very, very important, right? This is again the important problem from the in the view of a entrance, isn't it? So sin inverse 1 upon x square you can convert in the form of a cosec inverse x square. And what is the derivative of a cosec inverse x square? This is you have to substitute as a u. 1 upon minus 1 upon u means 1 upon x square root of u square means x to the power 4 minus 1, and the derivative of x square, that is equal to 2x. X get cancelled and you will get the result very easily, isn't it? Again, see the sixth one, that is d dx of sine of cosec inverse 1 upon log of log x. See, again, such a type of a problem, right? Again, if you substitute u, isn't it? Sin u, cos u. Again, you have to consider cosec inverse, this is u. Again, you have to consider 1 upon log of log x. That is again too lengthy, isn't it? Therefore, you have to think over on such a problem. What can you do? Now see, d dx of sine, and this cosec inverse you can convert in the form of a sine inverse again by taking the reciprocal of an angle. This cosec inverse you can write as a sine inverse. This you can write as a log of log x. See, the reciprocal of 1 upon log of log x you can write as a log of log x, and here the sine inverse sine get cancelled, ddx of log x. Right? Therefore, it's quite easy. This is again considered as a u, log u, that is 1 by u means 1 upon log x, and what is the derivative of a log x? That is 1 by x. Right? So in this way you can do the problem on what here? Inverse trigonometric function. These are the different type of a problem. Only I have taken only the one formula, that is sine inverse x. Similarly, we can take the problem on all the formulas, that is cos inverse, tan inverse, sec inverse. But here not the here we can't stop the inverse trigonometric function, because there are the so many problems on the every formula that I have given, isn't it? I have given the so many formulas. Here also you know the double angle formulas, triple angle formulas, isn't it? Half angle formulas. The problem, it is also depend upon that formulas. So the inverse trigonometric function, it is very vast, isn't it? So in the next video I am going to continue, that is the cos inverse, tan inverse, cosec inverse, all the remaining problem, right? So the student, if you like my video, please share it and subscribe my channel.